Hi everyone, welcome to my channel. This video is part of a playlist on AKS Networking, Azure Kubernetes Service Networking. What you see on my screen is a reusable and layered architecture diagram created using draw.io. I've created detailed videos on how to create this, so if you're interested, be sure to check those out. All the draw.io files, scripts, and the content that's presented today is on my GitHub repo link below. Today's topic is nginx Ingress controller. I covered application gateway as an Ingress controller in my previous video. So with that, we'll start with kind of understanding the use case for Ingress controller. Then we'll jump onto VS Code and build the cluster from scratch. While the cluster is building, we'll talk about core concepts, inbound and outbound flows, and then we'll deploy a sample application. Once the application is deployed, we'll run validations from the command line and the portal, and we'll close it out with some quick troubleshooting tips. So a lot of action. Let's get started. So if you've been following along with me, let me just get my mouse here. Um, If you've been following along with me, you'll notice that at the top left-hand corner, I have the series, and here I have the topic for today, which is nginx with CNI overlay, nginx Ingress controller with CNI overlay. Okay, and like I mentioned, if you look over here, it's a classic hub and spoke architecture, hub and a spoke VNet with a branch connected via a site-to-site VPN. This is a classic brownfield environment, so you could modify this to work with your customer, and depending on their requirements, you can start with this template and modify it accordingly. All right, so let's look at the use case for Ingress controllers. So as you know, Ingress controllers provide layer 7 functionality. So you could route based on the host header, route based on the URL. So if you can do path-based routing, multi-site hosting on the same IP. So this load balancer could have the same IP, and you can host multiple IPs. You could also multiple applications on the same IP. And you could also do HTTP, HTTPS traffic along with SSL termination. So Ingress controller gives you those layer 7 capabilities. Previously, we covered AGIC application gateway. In this session, we're going to cover nginx. nginx is also an in-cluster ingress controller. So in other words, the nginx pods will get deployed in the AKS nodes. Also, remember that with application gateway, it was not supported with CNI overlay plugin. And in case of nginx, we could use it with CNI overlay kubenet as well as Azure CNI. So it's supported in this video. We're going to do it. We are going to run the cluster on using the CNI overlay. So let's jump into the VS Code and deploy the cluster. I just want to touch upon, before I go there, I just want to touch upon one kind of use case for Ingress controller. As you could see here, there are two types of routing: virtual host-based routing, where you just specify the host name .companyname.com. So in this case, AKS red, AKS blue, green .companyname.com. So that's considered host-based routing. And then when you have a fan out, you do a /red, /green, and /blue. So this is considered path-based routing. All right, so with Ingress controller, we can do both the types of routing. So let's go ahead and go in our VS Code and kick off the cluster build out. So here I am. By now, the screen should look familiar to you if you're following along. Just checking if I'm connected to Azure, and I have an alias for K with kubectl. When I type K, I get kubectl. So now let's get the contacts. We'll clean up the, let's delete the overlay 99. I was using it before. And so we'll set some variables. As you can see, my plugin here is Azure because that's what is needed for overlay. So the plugin, and then here you could put in your values. I do have mine ready to go, so I'm going to just drop those in here. And we'll create a resource group. We'll go through this quickly. We've seen this before. Create a container registry. This video does build on top of my Azure CNI overlay video, so you may want to check those out for more details. So let's get the cluster deployed. So this is so we get the identity to deploy the cluster. And then we'll grab the VNet ID and the subnet ID. I do want to show you the VNet ID and subnet ID in the portal just to make sure that these two exist. Again, we are using a brownfield environment. So we will be using this overlay subnet, the 172.16.236 subnet, and this is the VNet in question. Okay, so we'll go ahead and grab those two IDs. We'll assign the network contributor role. And again, this is so that when we deploy services that talks to the Azure VNet, we have the right permissions to do so. Now, this is the important part. Let's look at how we build the cluster for nginx Ingress controller. So the rest of these should look familiar to you from before, but a quick recap. We're going to build a 3-node cluster with the plugin of Azure, and then since this is an overlay CNI, we'll have both of this network plugin and plugin mode. And the most important element here is enable app routing. App routing is where our nginx Ingress controller is going to get deployed. So let's go ahead and kick off this cluster creation. We do have the pod cider defined over here. So let's go back and look at all of the networks in the draw IO. So here, just to recap, in case of a CNI overlay, which is what we are doing today, the pod network and the node network are separate. Pod has its own different CIDR block than the node network in case of CNI overlay. And then, of course, there is that cluster network. So what we just kicked off was a cluster deployment, and it would deploy these 3 nodes. And the nodes will get an IP from the node network. Okay. And of course, any default Kubernetes deployment also deploys this external load balancer, mostly for outbound, and then you can set it up for inbound. So that's the deployment that we just kicked off, and it will also deploy because we specified the app routing over here. This deploys the nginx Ingress controller. So let's look at this a little bit more closely. It will deploy 2 pods. So these are the 2 pods, and inside the cluster, that's why this is an in-cluster nginx controller. And it will also put that in the back end of the load balancer. So in the load balancer, you would see in the backend pool that you would have 3 three IPs, and those would be the node IPs, and the node port is what it's going to do the health checks on. All right, so that's what we just kicked off. That's what this is going to give us: three nodes and an nginx ingress controller. Two replicas of an nginx ingress controller is what we're going to get. So let's look at a little bit more. Once we finish that deployment, we will deploy an application. So the application would look something like this. So we will have red, green, and blue services. And behind the scenes, that service would route traffic to the individual pods. So we have a deployment YAML and a service YAML files that would deploy this all of these resources. So let me just share this with you one more time. So this cluster IP, this whole yellow box with the different color pods is the namespace, and we have three distinct service: red service, green service, and blue service. I'll show you the YAML in VS Code when we get there. Let me take a quick look to see how our cluster is progressing. Looks like it's running. So while it's running, I want to explain all the flows. Again, these diagrams you could modify and reuse for your customers depending on your networks. You can modify it. So now that we have the nginx controller deployed, the pods and the services deployed, let's see how the inbound flows will work. So inbound, if you follow along with me, this user, if will connect to the load balancer. Load balancer would then have the backend as one of the nodes. And then from the nodes, it would route the traffic to the nginx pod or the ingress controller. From there, and then step number 5, I've kind of labeled all the steps. It will go to the cluster IP and then finally to the red pod. So assuming, let me just make sure we're following this. So this is the call that the user makes: AKS red.penguintrails.com, and then it will hit this red pod at the end. Of course, there is an FQDN there that is set up, and I'll show you how to do that in the portal uh, to make sure that this is more production ready. Of course, you can give host headers with curl command if you don't have the FQDN set up. So that's inbound traffic. Now let's look at outbound. Outbound would be very similar to the ones we've done before, where we will egress using the load balancer's outbound IP. All right, so those are the inbound and outbound flows. And so if you want to see the full thing, this is how the full ingress controller deployment looks like. Now, one thing I want to call out is this pink arrow right here. So from the load balancer, when you hit the nodes, there is a lot of magic that happens from when it hits the node to when it talks to the actual ingress controller. There's a lot of IP tables, rules, and a lot of layers of abstraction over there. So that's why I have this pink line. We can do a deep dive on that, but for now I've abstracted that layer of IP tables from this nginx ingress controller sort of overview. So let's go back in and check if our cluster is deployed. So there, the cluster is already deployed. It shows you how long it took. So now let's connect to the cluster. Now that we are connected, we should be able to get the nodes. Nodes got an IP from 10 to 36, 170 to 16 to 36, which was the network here, and also the network that is shown. Let me fix this. This should be 236. Okay, so that's the node network. Now let's go and look at the ingress controller. So first thing we'll do is we'll do get kubectl get namespaces, and you can see that this app routing system namespace is deployed based on enable app routing over here. And if you look at what the service and pods, you'll see that we have two nginx pods deployed. Okay, one got on pool. You can see that they're deployed on VM scale set 00 node here. And then we will do a describe on it. And when you do a describe on it, it shows you the entire flow that I showed you before, that what you have is a load balancer ingress. We'll look at it in the portal. This is the IP on the load balancer, public IP on the load balancer. This is the node port that each node is listening on, and these are the downstream endpoints. In this case, they both got deployed on the same node. I can tell by the IP of the pods, and also this output tells us that both the nginx pods got deployed on the node 00. And so let's look at this in the portal as well. So refresh this, and we have this cluster deployed. And if you go in the resource group, you notice that we don't see the load balancer. For us to see the load balancer, let's go into the resource groups. And we'll remember that special resource group with MC underscore. If we go there, we should be able to see the load balancer. So let's look at the load balancer before we do any kind of application deployment. So you can see that we have one front-end IP and one back-end, two public IPs. I apologize, two public IPs. One public IP is for inbound and one is for outbound. To see which one is for outbound, you can go in the outbound rules, and if you drop down this, you'll see that the 230.239 is for outbound. So this one is for outbound in this case. Let's look at the load balance. Let's look at the backend pools first. These are the node IPs 4, 5, and 6, 4, 5, and 6, and they should match with the node IPs that we saw before, this 4, 5, and 6 over here. Going back in the portal, let's look at the load balancing rule. Now here you have the three load balancing rules. This is for the Prometheus port. So we'll look at closer look at these two. Here, you could see that it's making a health probe check on this 32323 port, which is also the node port, and it's talking to that same backend pool, the Kubernetes backend pool where our nodes are. So let's double check the port here in the port in here. 32263 is the port, it's the node port, and that's what the load balancer is checking for health checks. So now let's go back in the portal, make sure we've looked at everything here. So that's your health probe on that port, and that's the load balancing rule. And we have one for port 80 and one for 443, and then we have the outbound rules that we looked at earlier. So far, if we go jump back in the draw IO, so far what we got is an AKS cluster with nginx ingress controller deployed. We haven't yet deployed the app yet. So let's go and deploy the app. So what we will do is, so these steps above were to validate the ingress controller. So now let's do the create color namespace. We'll do the red cluster deployment. So let me show you the red cluster YAML file first. As you see, it's a simple YAML file. You've seen this before. Deploys 3 replicas of the image, HashiCorp HTTP echo. It's a very simple image. It just echoes the text red when we connect to it on port 8080. And so this is the red deployment. We have similarly, we have green and blue deployment, each deploying three replicas. And then we have the service. Service is of the type cluster IP, and it will have the target port. It will listen on port 8080, and it will have the target port of 8080 as well. And similarly, we have the green and the blue service. So let's go ahead and deploy the red cluster, green and blue. Again, all of these YAML files are available on my GitHub. And let's see what it did. So we got the blue deployment, 3 blue pods, 3 green pods, and 3 red pods. And then the IPs are right here in the middle. And you can see that they got deployed in 10.2.44 network, which is in CNI, that the pod network is different from the node network. CNI overlay pod network is different from the node network. I did a deep dive on the CNI overlay, so be sure to check that out as well. So now that we have our services, the pods and the services deployed, let's deploy the Ingress resource. So I'll show you first this fanout.yaml file and then the virtual host.yaml file. So what is this fanout.yaml? Remember how we talked about having a host name or URL-based routing or path-based routing. So if we specify akscolors.penguintrails.com, that's the domain I own, /red, /green, and /blue, it will go to the corresponding services that we deployed. Okay, and the important thing over here is that the Ingress class name is set to be web app routing.kubernetes.azure.com. This was different when we had application gateway. The class name was Azure Application Gateway. And then, of course, the kind is Ingress. But the class name is the one that is different from the YAML for AGIC. Now, similarly, this is the fan out or the path-based routing, and then we have the virtual host, which is the host-based routing. So you can see that you have AKS red, green, and blue. They are different host names as opposed to a different path. Okay, so again, it's the Ingress class name is still web routing one, and then the kind is Ingress. So let's go ahead and deploy the two, run the deployment. So we're ready to, and let's do a get. So here we could see that, we saw the nodes and the service and the pod before, but the two new things that came about are the fan out and the virtual host that we created. Okay, and in the fan out, you can see that it only has one host name, and then we're going to use /red, /green, /blue. And in the virtual host, you see 3 distinct host names. Okay, so now that we have all of that, there's a useful command called describe. This is also useful for any kind of troubleshooting that you're doing. So let's do a describe on it. And it also shows the same kind of fan out here. And you can see that this is the IP address, the public IP address of the load balancer. Let's go ahead and validate that in the portal as well. So I'll jump back into the portal, and in the portal, if you see the front end IP, this is the 231.169, the last 2 octets of, and just double check here, 231.169. So this lands on the load balancer, and then let's also look at the other Ingress, the virtual host one. And you can see that that one has the different host names that also lands on the Azure public load balancer for inbound, and it's mapped to both these are mapped to, in the backend to the red service, green service, blue service, and the corresponding pods that are listening on port 8080. The pods are, of course, in the 10 to 44 network. So this is how, and similarly, this one being the virtual host, we're doing a describe on that, and it's also mapped to the red corresponding red, green, and blue service. Okay, so now how do we test this? Let's do a quick test, and then we'll do a deeper test. So a quick test would be, because we don't have the CNAME yet defined for this, you could just give the IP address of the load balancer. So we'll map it to the IP address of our load balancer here. And let's see if we can do a find and a replace. And we'll do a replace with our load balancer IP here, the 51, and then we'll just replace them all. Let's test it. There we get the red here. So we'll just test all of them, green, and we got the blue. And then we'll do it based on the host header of red, AKS red, green, and blue. On the top one, we were doing path-based routing. Now we're doing host name-based routing, and you can see that it's all working fine. All right, so far, of course, you wouldn't want to use IP addresses in production. Sure, I'll show you how to do it using CNAME in a few minutes, but let's go and just double check how these Ingress got deployed, these services got deployed in the portal. Because with App Gateway, we saw all of this in the portal. Now with Ingress controller, because this is Ingress, we will not see any difference in the, if you refresh over here, we don't see any of the red, green, blue services over here. The reason being that if you go back to the drawing board, the reason is that the intelligence is now here at the nginx controller level. So we don't see the services up in the load balancer layer. All right, so load balancer just talks to the nginx ingress controller, and then that in turn talks to the pod like we saw in the flows. So just be aware of that. So let me show you how to do the FQDN. So let's go back to the portal. So remember, this was the front end IP for our load balancer, the 231.169. So let's locate that front end IP. You can see that this is the public IP. Let's make sure it's the same one, 231.169, and making sure 231.169. Right, so what we will do here is for production scenarios, you want to use a proper DNS label here. So we'll just call it NN Ingress, just to kind of have a name. So let me just double check that's what I want to call it. Yeah, so we'll call it NN AKS Ingress, okay? And we'll save it. So now that the IP for the load balancer has a DNS label, NN AKS ingress dot east2west.cloudapp.azure.com, this will be your CNAME. So let's go back to the DNS zone for penguintrails.com. That's the domain that I own. And let's look at one of them. So if I go to AKS colors, I have created a CNAME record for AKS colors.penguintrails.com to map to that load balancer's DNS label that we just created, right? Sometimes people use IP address instead of CNAME, but for production resources, this is how you want to set it up. So this is for AKS colors, and similarly, I have done it for AKS blue and AKS blue dot penguin trails and green and red. Okay, so they are all done. You can see it over here. So now that we have our DNS set up correctly and we have a DNS label over here, let's go jump back in VS Code and see if we can target hit it directly the right way. So now let's try to hit it using just the domain name. Notice no IP address here, so we get the results. So everything's working fine here. And same way we'll do it based on the host name, red, green, and blue. We can also do some dig commands if you have to do any kind of troubleshooting. So you could also look up. So if we, let's say if we look up, if we run a dig against aksblue.penguintrails.com, you can see that it's a CNAME to this one. And if we run a dig against that one, you'll see that we get the A record, the IP address of the load balancer. So that's the full deployment of the Ingress and validations. Now, one of the things that I often get, from the customers is, what is this NodePort? So I did a quick kind of a lab to just check how the node ports are working. So let me show you one way to validate that. So what we will do is let's grab the node port based on this one. So we'll take a look at the colors dot. We'll take a look at this fan out. And then we'll look at this virtual host. So let's focus on the virtual host one. We'll focus on the on this one and grab the we'll grab the node port for the we'll grab the node port for one of the service which will do this blue service. Okay, so let's get the blue service. And if you do the describe on the virtual host, we get, oops, we want to do a describe on the service. So sorry about that. Let's go do a describe on the actual service, which is right here. So here, let me add a few more commands over here. So we'll do a k describe service. And then we'll describe this service. Okay. I keep colors.ns and we'll just describe this service. So here we see that we have a cluster IP and we have the back end IPs that are on the blue service. Now the biggest difference over here is that these have no IPs on the load balancer, right? So we don't have anything that's directly exposed on the load balancer. The reason being that in case of an ingress controller, only thing that the load balancer talks to is the node. So let's grab the service for the ingress controller and the node port, which is over here. So we will grab this node port from here. Okay. And each of the node is listening on that node port. So we will put We'll build our curled commands to validate the node port. And again, this is just an additional thing. I often get this question, so I thought I would incorporate this in here. So let's change this node port here, because that's our node port. And let's just verify that we do indeed have one of the nodes as the one that is shown over here. So 236.4 is indeed one of our nodes. And again, I grabbed this 32263 from the Ingress controller service. So remember, this is the app routing system namespace, and the service is nginx. So now that we have the node port defined, let's see how we can test this. So the way I do this is I deploy this tool called, I deploy this simple pod called network tools pod, and then we exec into that pod because it has all of the network tools that we need to run a few tests. So now that we are inside a pod, I can do an IP adder over here, and you can see that I'm inside. I exec into one of the pods, and then if we now hit the we've hit the service using NodePort, we should be able to get a response. Let's just double check demo gods, but that's the idea, is that we should be able to hit it from there. So this is the 32263, and here we can specify the AKS blue. Let me just double check here. Not sure what I'm missing here, but I can come back and revisit this. But basically, the idea is that we should be able to hit it on this node port. Each of these nodes are listening on the node ports, and we should also be able to hit it on the likewise on the cluster IP. And the cluster IP, let's just double check that. Not sure what I'm missing there, but let's grab the cluster IP over here. And let's put this, let's see if we can run that test. There, we can hit it on the cluster IP, and we get blue. So I'll post a comment once I figure it out, or I'll make a note in my YAML file once I figure out what the issue is with the node port, and we can test it after. So now that we have all of these, just let me just show you a couple commands to let's exit out of this network pod. And let me do, you can do the kget events command, of course, in the colors namespace. You do, and this is a very useful command. If there's any problem, you could get more insight into it. There's a couple other commands. You could get the DNS, verify DNS over here. I've done a detailed video on this before, so you may want to check that out. And lastly, let me just show you. You can use this command to delete the resource group, and it will delete everything. And the final diagram, now that we have seen this, looks something like this. You have, first you deploy the nginx controller, then you deployed the different nodes, different pods and services, and then the inbound flow looks something like this. So you go from the user goes to the load balancer. Again, this pink flow is lot abstracted using IP tables, and So there's a lot of abstraction that happens over there, but eventually the intelligence is the layer 7 intelligence is in the ingress controller, and then you do the outbound flow over here. And as you can see, the outbound flow goes through the external load balancer. And that's it for today. Thank you again for joining me. Hope you enjoyed this session. Drop me a note if you like to see any more videos on any other networking topics. Thanks.